All right, guys, lesson 4, solving right triangles. So this is it, our very last lesson. And I just want to read this. It says, to solve a triangle, you need to find all missing side lengths and all of the missing angles. So if we look at this first question down here, the example, it says, solve the following triangles where two sides are given. So in this case, we have two given sides. We don't have any angles other than the fact that we know that this is a right angle triangle. So we can use any of the strategies that we've learned so far. We can use our trig ratios, so KOTOA. You can use the idea that the sum of the angles in a triangle is 180 degrees. And we can, of course, use Pythagorean theorem to find our missing side lengths. Okay, sometimes we have many choices because there are quite a few strategies that will sometimes lead to the same answer. So if we look at this first one, I want to find the missing sides. So first, let's just go with the missing side. If I want to find this missing side, this vertical side length right here, which I'm just coloring over in blue, we could label this. That might be easier. Let's call this, A, B, C. So this would be side B, of course, this would be side A, and this would be side C if I'm labeling it according to just some letters. I'm just picking random letters, A, B, C. So my angle and my side opposite each other would be smaller case, lowercase, and uppercase letters. So if we wanted to find side C, okay, so let's find side C. I'm going to use Pythagoras to do that. So side C would be the square root of my hypotenuse squared minus one of my legs squared, right? This is the hypotenuse. I know that has to be the biggest side. So it's 5 squared minus 2 squared. So C would be the square root of 25 minus 4, or the square root of 21, which if we just plug that in our calculator, we will get 4.58, which we would round to 4.6. Okay, 4.6 units, whatever those might be. All right, and it says to round side lengths to the nearest tenth. So we want 1 decimal and angles to the nearest degree. So no decimals there. And now, if I know that this is 4.6 units, in order to find one of the angles, angles C or A, I would have to use a trig ratio because I don't know two angles. So I would have to use a trig ratio. We could use any ratio we wanted because we now have all three sides. I'll just stick with the ones that we started with. So the 2 and the 5, that would be our adjacent side with respect to angle C, and our hypotenuse. So I want to use the cosine ratio. So in order to find angle C, which is my big capital angle C, I'm going to set up the cosine ratio, which would be the cosine of C is the adjacent over the hypotenuse. And my adjacent side would be 2, and our hypotenuse would be 5. And then, of course, to find angle C, whenever we're finding an angle, right, we use the inverse cos of 2 over 5. And therefore, angle C would be 66.4, so 66 degrees. All right, so this is 66 degrees right here. And then to find angle A, the easiest way, we could, of course, use another trig ratio, okay? But angle A, we can also just do angle A is 90 minus 66. And 90 minus 66 is, of course, 24 degrees. So now we've solved our entire triangle using a variety of methods. Okay, down here, let's try the next one. Why don't we find, first of all, why don't we start with finding a missing angle? So let's label these again. Instead of ABC, let's use, I don't know, PQR. P, Q, and R. And notice I'm putting capitals at the points or the angles, right, the vertices. So if this is angle P here, this 18 would be little p. Big R, our hypotenuse would be little r. Big Q, this opposite side would be little q. So if I wanted to find, let's start by finding angle Q. Okay, let's find angle Q. If I want to find angle Q, I need to label my triangle with respect to angle Q. So this would be the opposite of Q, and this would be the adjacent of Q, and of course this would be the hypotenuse. So opposite and adjacent are what the ones we have. So if I want to find angle Q, I'm going to set up the tan ratio, and I would say the tan of my angle is the adjacent, or sorry, the opposite over the adjacent. So what do I put in the first? The very first blank is the angle. So we're finding angle Q. Okay, so tan of Q is my opposite over the adjacent, 24 over 18. And if we just do a quick inverse tan of 24 divided by 18, we'll get 53 degrees. So angle Q is the inverse tan of 24 over 18, right? We're given the ratio, so we want that angle. And angle Q is, of course, 53 degrees. Okay, so if there's 53, and if we want to find angle P, that's going to be 90 minus 53, which is 37 degrees. And then once we know those two, if we want to find our missing side R, we could use Pythagoras, or if we wanted, we could use one of our trig ratios. So let's use a trig ratio. I'm going to go from P. Well, I won't go from P. I'll use Q because then I don't have to relabel according to opposite and adjacent. So let's use angle Q. If I want to use angle Q and I want to find this side R, I want to use one of my ratios with hypotenuse. So if I think of SOHCAHTOA, I can either use my cosine or my sine ratio because I want to find the hypotenuse. So I need to use one of the hypotenuse ratios. So let's just pick one. Let's just go with sine. Doesn't really matter which one, but let's try sine. Okay, sine of Q, so sine of blank is blank over blank, an opposite over hypotenuse. We're going to use the hypotenuse, and because we're using sine of blank, 53 as our Q, 53 degrees. So let's put that in a different color here. So we're using 53 degrees. Sine of 53 is the opposite, which is 24, over the hypotenuse, which is R or X. Okay, side R or our missing side, we can call that X. Okay, let's just fix that 3 up there. And now we're finding a missing side, so we're going to cross multiply again. So we've got sine of 53 times X, which is sine of 53X, and 1 times 24 is simply 24. And again, this is just like saying, 2x equals 24. We would divide both sides by 2, but instead of dividing by 2 here, we're going to divide by sine of 53. Divide by sine of 53. And those two guys will cancel. And we're just going to plug that in. 24 divided by sine 53. Let's find that calculator. 24 divided by sine of 53. And we get 30.1. 30.05, which rounds to 30.1. Okay, so 30.1 feet, I guess would be this length because they're feet. Okay, does that make sense? Hopefully that makes sense, and you can try that. Why don't you guys try the next example? Okay, pause the video and give it a try just to hammer home and make sure you know what we're doing. Okay, so hopefully you got the same answers as I did. I just randomly chose X, Y, Z as my angles, and therefore I have side X here is 29.3, and my two angles were 38 and 52 degrees. So let's look at the next one. It says, example, solve the following triangles with two angles given. So it's not obvious because we only see one angle measure here, but we do know that this right angle is, of course, 90 degrees. So we are, in fact, given two angles. So to find that third angle would be super simple. Let's just label this, I don't know, let's call it M, N, O. I'm just randomly picking letters again. So this would be opposite here. This would be side M, and this would be little side N, and this would be little o across from the big O. Okay then, so if I'm looking for angle O, that would be the fastest here to find. Angle O would be 90 minus 71, which would of course be 19 degrees. Okay, so angle O we know is 19 degrees. And now if I want to find my two missing sides, I can't use Pythagoras because you cannot use Pythagoras unless you have two sides. So I'm going to be forced to use one of the trig ratios. So I'm going to relabel my side lengths here. I'll use 71 as my reference angle. You have a choice. You could use 19 or 71, but if I use 71, then this is my opposite side and this is my adjacent side. And this, of course, would be my hypotenuse. Had I chosen to use 19 as my reference angle, which I could have, then of course my opposite would have been, this here would have been the opposite, and this one here would have been the adjacent had I used 19. But I'm not going to use 19, I chose to use 71. Okay, totally random. So let's have a look there, and if I want to find then my opposite side, say, then that would be opposite, and I have the hypotenuse. So when I consider my SOHCAHTOA, if I have my opposite and hypotenuse that I'm finding, then I'm going to set up sine of blank is blank over blank, opposite over hypotenuse, always. What goes in the first blank? The angle goes in the first blank. In this case, my angle is 71 degrees. So sine of 71 is m, side m, we can put x or m, whatever you want, over 10. That hypotenuse is 10. And now because we're missing a side, we're finding a side length, we're going to cross multiply. So x, 1 times x is x, which is 10 times sine of 71, right? We're just cross multiplying. 1 times x, 10 times sine of 71. And when I multiply that in, we get 9.455, which would be 9.5 units. It doesn't say what the units are in this case. Okay, so 9.455 would be 9.5 units. And then again, if I wanted to use trig again, this one is 9.5. If I wanted to use trig again, I could use one of my ratios. Okay, we've got lots of choices here because we have two sides. I could use ratios, or I could use Pythagoras. I could say side O is the square root of, okay, I want to find side O. I could say side O is the square root of 10 squared minus 9.5 squared. And if I plug that into my calculator, literally plug it in, I will get 3.1 units. Okay, so that's this one here. That's 3.1 units. So there's how we would solve using two angles. Okay, let's just skip the next one. I think you probably have the idea. And again, you probably got the idea here. You know, 90 minus 38, use a trig ratio. I can give you the answers to this in just a second. Let's if you want to try this one, okay? I'll give you a minute to pause the video, but let's try the next example, and I would like you to try 2 tries. The next one, this sketch and solve, this is quite critical that we are able to interpret these. We've done a little bit of this in the last lesson or two. It says a right triangle has an angle of 21 degrees, okay, and an opposite side length that is 7.4 centimeters long. So let's draw this. It says sketch the triangle. So I'm going to just sketch a nice right angle triangle. Okay, and then of course there's my right angle right there. And it says a triangle has an angle of 21. So this would be my 21 degree angle. And my opposite side length is 7.4. Okay. Now this isn't the only way I could have drawn this. I could have drawn this, you know, I could have drawn it like this. If it's a right angle triangle, I know that there's a right angle somewhere. So here would be my right angle. One of these little guys here, one of the other angles would be my 21 degrees. So I'm going to choose the smaller one. Okay. And the opposite side length is 7.4. Okay. So I need to be able to draw that triangle. Okay. Draw a right angle triangle, choose one of the smaller angles to be the 21 degree. Okay. And then if this is 21, it says solve the triangle you sketched in part A. So I would like you to finish solving that, and then I would like you to try drawing this one. So 3 tries here. Try this, solve this, and try at least the sketching here. Okay, try to do the sketch. Okay, go on now. You can pause the video and give that a try. Okay, so before I forget, let's just say that the word of the week here is, or the fantastic, let's make that fantastic job. Okay, you guys have all done a fantastic job. So impressed. Maybe no exclamation there, so that you get your answer marked correctly. But anyway, those of you who have gone through the videos, done the assignments, you're really going to be ahead of the game for next year, because if you haven't, of course, it's going to be a bit of a struggle. And if you are going on to higher level math, make sure that you have watched the videos and done the assignments. Okay, so for the try here, hopefully you got the same answers as I did. We've got a 25 millimeter for this missing side F. This would be a 25 millimeter 0.0, right? If we round to the nearest tenth, we should have that 25.0. That just indicates that we've rounded to the 1 decimal place. And E here, side E, which was 40.6 millimeters. And we found our missing angle here of 52. So there we go. And regardless of which order or which strategies you use, you should get something very close. Sometimes we're off by a decimal on our rounding, but generally speaking, we should be getting the same answers. Okay, for the next one, our answers should have been 7.4, 19.3, and 20.7. Okay, in terms of our side lengths, and the one was already given to us. I guess we had the 7.4, and our angle was 69. And for the final one here, I've solved it. Our missing side was, of course, 11.2. That was our hypotenuse, and our two angles were 27 and 63. So hopefully you took a time and tried those. If you're looking at the assignment, I would just do questions A and C for number 1, and then do the higher level ones where you have to draw the questions for 2, 3, 4. So that's 5 quick questions before you attempt the assessment. Again, as always, if you have any questions or concerns, please do not hesitate to contact me, and I hope you're having a great day. Thank you.